Hi, this is Group 2's presentation for MIS 7610, Systems Analysis and Design. In this presentation, we will have an overview of the Global Paper Company and the software development lifecycle steps completed for the development of the generic inventory inquiry application. The members of Group 2 include Brett Rayberg, George Spake, Manasa Karusala, Aneta Jumanchek, and Terry Hardaway. Paper and paper products are used in almost every facet of our lives. From the currency we use to purchase things to the disposable lids covering our hot beverages, we are touched by the paper industry everywhere we turn. The United States is the second largest producer of paper in the world, with almost a fifth of the global production. That accounts for 75 million tons of paper products each year. With more attention given towards recycling, the industry is shifting towards recovering paper rather than virgin paper production. Recovered paper is one of the largest exports from the United States. The paper industry has trade flows all over the world. In 2011, the top 5 trade flows produced a total of $60 billion in paper products. In North America, the paper industry has had no growth in the last few years. Founded in 1898, the Global Paper Company is an American paper and pulp company. As the world's largest paper and pulp company, GPC has reported $28 billion in annual revenue and employs nearly 70,000 people around the world. GPC produces 4 million metric tons of paper and pulp each year. Now let's take a look at the steps completed in the planning phase. At GPC, SAP Application Development Services, or SAP ADS, is a software development group within Information Technology Global Operating Model Application Services, which is also known as IT GOMAS. The objective of SAP ADS is to provide quality SAP custom development solutions and deliver them in a manner that meets or exceeds the customer's functional requirements. SAP ADS is focused on enabling business initiatives through building, implementing, and sustaining custom solutions that work either as standalone applications or complement larger functional systems. The GOMAS organization has a website called Order IP that is used for online access to SAP data. Part of the strategy for the next year is to provide mobile access to the Order IP functionality. The problem is that the current website does not work well with mobile devices. While this application will not provide access to all of Order IP, it will provide users the ability to look up inventory levels for specific products. This functionality was highly requested and is expected to offer improved customer service. GPC is currently investing in its online presence by enhancing the Order IP website. The web portal has been upgraded to support HTML5 and multiple browsers. The next step is to enable access to Order IP functionality through native mobile applications. Initially, these basic apps will focus on connectivity, then work to improve performance. Advanced mobile features such as push notifications of order status will be added later. The SAP ADS team has been researching emerging solutions that will enable existing team members to create mobile business applications. The current system has been implemented as a throwaway prototype to allow developers to gain initial exposure to new and unfamiliar technology. The backend server uses the SAP NetWeaver Gateway product to expose existing business data through the use of OData web services. The Xcode Development Studio from Apple was used to create a native iOS application that serves as a mobile front end for the SAP data. The implementation of this proof of concept system has been successful and allowed the team to learn a lot about mobile development. However, the current backend installation technique uses an embedded deployment in a single sandbox system and is not recommended for productive use. In order to move forward with mobile business applications, the 2B gateway system will need to use a centralized deployment strategy with connections to multiple backend instances. This will require contract negotiations for software licensing from SAP and possible investments in new hardware. In addition, policies will need to be put in place to control data exposure outside the corporate network. This enhanced infrastructure should enable GPC to remain competitive in the market through increased data visibility and faster user response times. There is some initial risk created by a shortage of technical capability in new development areas, particularly for creating the native mobile application experience that users may be expecting. The yellow stars in the following diagram indicate these areas and how they fit into the existing landscape of GPC. The central hub deployment described previously would mitigate risk in the DMZ layer by handling the external connections and limiting the number of internal connections required to reach the backend SAP servers. Later in the presentation, we will discuss specific tools that will be used at various stages of the software development lifecycle to address these issues. The company previously provided an external call for customers to build their own mobile inventory check applications. These companies average 900 inventory checks a month through the solution. Accompanied with the remaining statistics acquired during the study, it's easy to see that the creation of this mobile application will be beneficial for the company. We identified 4 phases for the implementation of mobile applications: scope planning, requirements analysis, prototype design, and development. These tasks will generally happen sequentially based on SDLC. These steps are the focus of the presentation and will be expanded upon later. These steps take place at the end of the design phase to determine the user interface specification and data storage design. The development process is broken into specific tasks to allow each individual developer to focus on activities related to his or her strengths. Here we start with review of the data model and technical specifications with the development team. The mobile architect and development manager identify the modular components. Next, the developers are assigned to work on each of the individual components. ABAP development specialist develops the OData web service in the SAP backend. The mobile developer creates the application to consume the OData web service. For complex applications, this task may be outsourced as necessary. Primary debugging and developer testing of the application is completed. These are the steps identified for post-implementation: testing, training, documentation, pilot deployment, and post-implementation review. In this section, we will discuss the software development lifecycle for mobile applications that would be developed by the SAP ADS group at GPC. The SAP mobile platform acts as a middleware component to add enterprise qualities to custom mobile applications. This Java-based server can support several deployment options, either on-premise or in the cloud, but is not required for initial mobile application development. SAP NetWeaver Gateway runs as an ABAP application server and transforms SAP data to OData. OData is a standards-based communication channel that is easy for both humans and machines to work with. This product is required with either current embedded deployment or proposed central hub deployment. The SAP Business Suite provides the system of record for ERP, CRM, SCM, APO, and BW data. The SAP ADS team has traditionally produced applications to work with this data. Also on this layer, SAP Solution Manager is available to integrate with mobile application development. The specifics covered by this project will relate to a particular application known as the Generic Inventory Inquiry application. The Gen app is the actual application being built by the SAP ADS team that will be documented throughout the SDLC process shown in this project. With the completion of the project scope, we moved into the analysis phase where we solidified the requirements, developed use cases, and designed process and data models. For requirements determination for the backend portion of the system, we use technology analysis to focus on the SAP NetWeaver Gateway. This is a new solution not currently in use by GPC, but has the potential to provide access to SAP Business Suite for multiple application servers. The development team used document analysis to review system documentation, assess currently available capabilities, and create a deployment roadmap. This approach enabled the team to become more familiar with the technology and determine how to best install and configure the product for productive use. After acquiring sufficient supporting details on proper implementation, The development team conducted interviews with other technical teams to evaluate the facilities required for central gateway deployment, and additional hardware or licenses can be acquired as necessary. We completed an outcome analysis to identify business capabilities that the new system must eventually support. This portion of the requirements analysis phase began with a series of targeted interviews, starting at the top with various managers to identify the appropriate business user community. We then engaged individual process managers and power users to determine what data could be useful and how it might be presented in a mobile application. Finally, a series of joint application development sessions were held to bring developers and users together to identify requirements for the pilot application. This mobile application is targeted at actual business use cases that will showcase system functionality without excessive features. Now, let's take a look at the functional requirements. For the OData channel for SAP Gateway Backend Server Enablement, the exposed web service should authorize users based on SAP security settings. NetWeaver Gateway will enable access to SAP backend data and functions. The existing SAP functions and data models will be reused where applicable, and system output should conform to the publicly available OData standard. For the iOS device-specific mobile application for generic inventory inquiry, the pilot application will allow business users to check generic inventory details. Choosing an individual account will display products assigned to that account. After selecting a specific product, available inventory details will be displayed. And finally, products can be marked as favorites and details stored for offline access. Now let's take a look at the non-functional requirements. Under operational issues, the central gateway deployment will provide data interfaces to internal SAP instances. Applications could access the SAP gateway from outside the corporate network. For security considerations, applications should only provide access to data for an authorized user, and the data cached for offline access should be stored in an encrypted format. Under performance evaluation, the inventory data is available for real time, but response time should be optimized for mobile applications. And the project will focus on a limited subset of users, as the total for the final system is unknown. Cultural and political concerns. Mobile devices will be expected to comply with the existing company BYOD policies, and the web methods SOAP-based web services are not preferred for mobile applications. In the first use case, the data from SAP is displayed on the generic inventory inquiry application. The user launches the generic inventory inquiry mobile application, chooses stock code, and submits the selection screen. Then the inquiry results are displayed on the screen. In the second use case, the user's access is authenticated and the user is allowed to use the functions of the application. The user logs into the application on the mobile device. Then the user accesses the needed inventory modules, and the user has preferences to save his or her favorite items. In the third use case, the security features are enforced. Once the user enters his or her login credentials, the system validates their access permissions and allows the application to have access to the inventory information. Once the user is done using the application and closes it, they're logged out and the system clears the device cache. In the fourth use case, we look at the generic inventory application performance evaluation. The user tries to access the application. User tries to access the multiple files simultaneously in the application. Then the user tries to access large files over a mobile connection, and the user multitasks with other mobile applications. Here we show the process steps for inventory inquiries as completed across the web, comment, and XML functions. Now let's take a look at the data model diagram. The Open Data OData protocol is a standard protocol used to provide access to data via HTTP. It is the protocol that the mobile apps developed by GPC will use to interface with the SAP NetWeaver Gateway. GPC will use the Gateway Productivity Accelerator, OData Modeler, and tools to manage the data modeling process for its mobile apps. GWPA is a set of developer tools for Eclipse to enhance the data modeling process. It includes a graphical modeler that can be used to create entity relationship models that can be exported into a standardized format for use in the development of the application and the creation of OData services that they will allow to app to interface with SAP systems. This means that relatively little work needs to be done following the modeling process to integrate the model into functional application. GWPA includes toolkits for various platforms. The toolkit used may depend on whether the mobile application will be deployed as a native, hybrid, or HTML5 application. The traditional data modeling and normalization process still applies and is based on the functional requirements of the mobile application. The mobile architects responsible for modeling the data must understand that the model process and how the requirements will influence data structure. Now let's explore the steps to complete the design phase. Our acquisition strategy requires both back-end and front-end. For the back-end enablement, the NetWeaver Gateway software package would be purchased from SAP and installed on premises to allow access to SAP data through the OData web services. There are two options for deployment as detailed in the project overview. Embedded means each SAP data server has its own gateway components. Central Hub means that the gateway system that is connected to each SAP server. For front-end interface, the acquisition strategy for mobile application varies based on the case-by-case basis. Simple applications like the generic inventory inquiry app found in this presentation can be built in-house by current development staff. SAP also provides several standard apps such as workflow approval that can be purchased and customized to meet business needs. Finally, complex mobile apps will require many interconnected screens or rich user experience can be outsourced to mobile-specific developers. There are advantages and disadvantages to each mobile application development platform. Native applications generally offer the best features, usability, and performance. They also offer faster graphics, which is important when working with large sets of data. Native applications also provide users with complete access to the device, hardware, and access to applications regardless of internet connection. However, native applications are not the easiest to develop. They require experienced developers with knowledge of programming languages such as Java and Objective-C. Native applications can also be expensive to develop and maintain with the need to rewrite the application for each mobile operating system. Web applications are essentially a series of web pages designed to work on a small screen and are usually developed using standard web technologies such as HTML, CSS, and JavaScript. Creating applications for multiple mobile operating systems does not require rewriting the code for each platform. Developing web applications does not require a high level of development experience. The lack of a standard screen size and resolution for mobile devices increases the need to test different devices. Also, web applications limit the user access to native device functionality and require the internet connectivity for any usage. Hybrid applications combine some of the positive and negative traits of native and web applications. They are essentially web applications built in HTML5, CSS, and JavaScript, wrapped into a thin layer of native container to provide access to native platform features. Hybrid applications also allow the user to access the application offline. However, they're not easy to develop and require a high level of expertise. Mobile applications use a client-server type architecture. By using SAP Mobile Platform and OData, we create an open communication standard for application clients. Each OData web service exposes a custom application data model, which individual clients can access with separate libraries over the same protocol. This means that the mobile client could be any kind of device such as iPhone, iPad, or Android phone, or simply a web browser on a mobile phone. The same back-end logic can provide data from the server to the clients over the OData protocol. Here we have a list of each entity with descriptions and some of their properties. All of the data in the data store will be used in the views that the user interacts with in the application. Some of the views presented to users will correspond directly to single entities in the data store. For the other more detailed views, entities can be joined and processed to present data that is not explicitly stored. Here we have screenshots of the steps as defined within the use case specifications. The first image shows the iPhone home screen. The next image shows the login screen where the user can submit his or her credentials for authentication. The third image shows the application's settings screen. Now let's take a look at the main functional screens of the application. The first image shows the main inventory query screen where the user can search or scroll through the various products available. The other two images show the inventory and item details. Security plays an important role in the application design, and we have taken all possible precautions to make the application secure. We use the company SSL certificate to modify the security profile of the device with reference to the company's application. Number 1, the device password must be set up to access information. 2, the user is required to re-log in after the device is locked. 3, the user's ability to set up the device to never lock is disabled. 4, verifying that the company account has been removed from the device before the device password can be removed. 5, the user cannot have a 4-digit simple passcode. 6, the application cannot connect to other applications on the phone. 7, the user is required to register the device MAC address. And 8, the user is required to update his or her password regularly. Now we will take a look at the steps completed in the implementation phase. The application was deployed into the production environment after successful completion of the following testing phases. System testing. In this phase, we tested the application in the test environment set up to simulate the production environment, incorporating the complete integration as well. User acceptance testing. In user acceptance testing, or UAT, we collaborated with the business team using the test cases developed with respect to the business functionality and business requirements. Load testing. In load testing, we tested the limits of the application by seeing how many users could use it simultaneously via automated testing. The implementation of the system is expected to be smooth as we are not expecting any reluctance from the users, as this is the start of a new era in the mobile usage in the company, but the users are not giving up any current systems or functionality. We will initiate the application in a step-by-step process that will take the application online slowly, giving us a chance to work on any unexpected breakdowns. This will also give us a chance to add resources to the most widely used sections of the application and speeding up the process there. Training sessions will be conducted to explain the functionality of the application and provide the power users with internal functionalities that they are not widely used. We will also create user manuals to help the users with screen prints and detailed instructions on going through complex processes. That concludes our presentation. Thank you for your time.